So with that, I'll go ahead and introduce Dave Hattie from Lockard & White, and he will take over for now.
Good morning. And thank you, Bob. So, as Bob mentioned, I'm currently a consultant with Lockard & White, and we've been through this process with a number of utilities. But my own personal experience with this goes back about 45 years. And in the early 80s, I had the joy of putting in one of the first field area networks at a utility that was a VHF DTMF control system to let us switch our capacitor banks in real time. And we gained a couple of points of efficiency by doing that, and started the whole process for that utility of moving down this road. The second thing I want to mention is about 10 years after that, I happened to be at GE Mobile, where we were working on GE cellular system, and had the joy of taking the GE cellular modem chip, which did, as you may recall, the old guys in the audience may recall, did 10 kilobits and 30 kilohertz of RF bandwidth. We took that and leveraged it down to do 9600 baud and a 25 kilohertz bandwidth. And that let us create the first digital trunk systems and the first 9600 baud digital voice systems. And this again was back in the late 80s. So the history of figuring out how to manage and control the equipment you have in the field, in the grid, and the history of figuring out how to take cellular technology and leverage it to help us in our little microcosm of a market. I mean, compared to the worldwide cellular market, we are nothing. But by leveraging their technology, we can do a lot of different things. And that's really where this discussion starts and the direction that it heads. The other thing that I'm very fond of saying, having been in the market, in this industry since the 70s, is, if I go back 30 years, I knew where the big generating sources were. I knew where the sources of our electricity were. I could count them on the fingers of my hands. And I knew where there was the few hundred big users of electricity. And those are the people we had to hook together, get the plants out to the big users, and then cover everybody else too. And how do you manage that, and how do you keep it live? Well, what you all are living through for the last decade or decade and a half is a complete revolution of how we make power, how we deliver power, who is getting the power, and how do we have to manage that. The first thing was big coal-fired generating plants went out of popularity. The government's telling you, shut them down, shut them down, shut them down. You've got all these distributed energy resources coming in. You've got all these small plants coming in. And suddenly you didn't worry about the big iron forging plant being the one you had to keep power in, or the big car plant being the one you had to keep power in. Now it's the data centers, and it's all of the electrical vehicle charging, and it's all of the renewable farms. And you've got to control all that. So over the last decade, your need for a field area network and your need to be able to manage all that has changed 100%. It's a complete revolution. And as an old engineer, this is fun as heck to live through, because there is a lot of new stuff we get to do, a lot of new things we get to touch. As an operating utility, I'm sure it's scary as scary can be. And one of the joys I have as a consultant is working with a lot of you as you go through this decision process. As you look at that revolution, you look at what's changing on your grid, and as your senior executives figure out that telecommunications isn't this red-headed stepchild, ugly little necessary evil we have to have, but that in fact telecommunications is the way you have a resilient, secure grid. And in fact, if you don't have good, resilient, secure telecom, your ability to manage that grid is going to go to heck in a handbasket pretty darn quickly. So you need some way to manage your field area network. There are 1,000 ways to skin that cat. And the decision you make about how you skin that cat is really going to be driven down to your business case. What are the applications you need to bring onto this network? What are the financial cases that those applications provide you? What's your overall appetite for capital expenditure, operational expenditure, and risk? and what's your appetite for resiliency of both your telecom network and your electric grid. So as you go through the choices, the previous presentation, so JJ and John did a great job about talking about how Evergy's gone through this process and how they're applying it. I sat in a couple presentations yesterday that did a very good job of explaining how to get resiliency out of a non-resilient system, because the public carriers, even FirstNet, as we all know, are pretty non-resilient. But there are ways to get resiliency out of that. There's also the traditional way to get resiliency, which is to go build a purpose-built network that is built to your standards of reliability and resiliency, and maybe using narrowband channels, maybe using, today more likely using wideband channels. And a subtle distinction there as we go through the charts. Narrowband is a traditional 12.5, maybe some of the 25s. Wideband is 25, 50, 100, even 200, with higher level modulation schemes that let you pack some data into that puppy. And when we talk broadband, we're talking about cellular, or LTE. And as we've heard over and over again, and all of you are living, LTE is really constrained by both the 3GPP standards and by what spectrum is available to 1.4 by 1.4 or 3 by 3 or a 5 megahertz time division slot, or if you've got 2.5 or CBRS, you may have 5, 10, 15 by whatever, because you have the space to do it. But that is also driving a financial trade-off. So just looking at some of the characteristics, and I already know there are some errors on this slide. I mean, JJ and John just said that JJ has measured 50 megabits in a sector of his 3 by 3 900 meg LTE, and I only gave it credit for 25 megabits, so I'm off by 3 dB already. But this is meant to paint what is the overall picture, what are the trends. So as you look at a traditional wideband versus an LTE or private LTE, of course, the data rates are higher, but on traditional wideband, the latencies are much lower. John mentioned high reliability, low latency communications as being part of 3GPP. That is true. Today it takes 5 megahertz to get there. But even with the low latency communications in 3GPP, you still don't get a guarantee of anything better than 100 to 200 milliseconds for your latency, which for a lot of our applications, that dog doesn't hunt. Of course, the traditional wideband were higher power levels, so we get more coverage area per station. One of the keys is because the traditional wideband wireless, you're dealing with non-contiguous spectrum, so you need little chunks, 50 or 100 kilohertz, that don't need to be contiguous. That constrains the value of that spectrum to 50 cents to maybe $1.50 per megahertz pop. And whenever we talk about spectrum, I'm sure you all know this, but we talk about per megahertz pop because you need to look at how many megahertz of bandwidth, or kilohertz in this case, of bandwidth you're buying, and what population you're buying it over. Multiply those two together and multiply it by the price per megahertz pop, and you get what the asking price is for that spectrum before you start the negotiation process. On the other hand, if you're trying to build an LTE system, you need at least 1.4 by 1.4 a contiguous spectrum. So you need 2 slices of 1.4 megahertz contiguous, spread apart for RX and TX, or 2 slices of 3 megahertz contiguous, or a slice of 5 megahertz contiguous. Because you need a lot and you need contiguous, the value per megahertz pop jumps up. I mean, I think the cheapest we've seen is $1.25 a megahertz pop, and we've seen $3 per megahertz pop. So if you think about the population of the area you're trying to cover, that changes your price position pretty darn quickly. And that's what we tried to capture in the spectrum needed. Just the spectrum cost, the trade-off between a traditional wideband system and a private LTE system is somewhere between 5x and 10x, just in the spectrum cost. Now that's fine because there's a huge value differential too, but as a utility, you've got to figure out, does the business case for the applications that I'm bringing to this network, does the offset costs that I'm offsetting with this network justify that additional spectrum cost. There are differences also in how do you manage it going forward, what skill sets do you need to manage it, and more specifically, how do you manage adding user equipment? So one of the neat things about LTE is the system is managing the spectrum for you. So adding more user endpoints is just a matter of adding more base stations, either sectorizing existing sites or doing an overlay or an underlay, and the system will manage all that for you. That's cool. But if you're over in a traditional system, we still do it with channel base. So there's a channel reuse scheme. We're doing a lot of engineering to figure out what channel we're using where. And if you suddenly need a lot more capacity, you got to go back and redesign the whole channel layout, and that is a non-trivial task. So there's a lot of trade-offs, but what is it you're going to do with this network once you get past those trade-offs? So we tried to capture just the general applications: relaying, SCADA, DA, DER, demand response or power control, dispatch voice, workforce management or mobile data, advanced meter reading, and smart metering. And for each one of those, we tried to categorize, and again, these are broad brush strokes. Individual utilities may look at this and say, well, ours is different than that. Well, it may be because over the last 30 years, we've all implemented things differently. But fundamentally, the latency driven is the heaviest for protective relaying. You need really short latency for protective relaying. We talk about cycles or fraction of a cycle at 60 hertz. Down to things like metering where, it's not too bad if it takes a while, or workforce management, it's not too bad. Because when we define a while in these networks, we're talking about hundreds of milliseconds. We're not talking about minutes, hours, days. We're talking about fractions of a second. But when we talk about protective relaying, we're talking about single-digit milliseconds or maybe low two-digit milliseconds to pull it off. And that does a lot of driving of what kind of network you're going to build to do it. Also, you have to look at the data rate required, the density required, and mobility. One of the things that's very important, and a couple of folks over the last 2 days have referenced this, right now today, 3GPP does not define mobility on a 3x3 slice channel. Anterix is working hard to get that in, and I think they will succeed. It makes sense that they will succeed. But the minute you say mobility, seamless roaming, that's a whole different layer of complexity, and it's a whole different layer of the 3GPP standards versus what we traditionally do, which is point-to-point data. And we're not saying you can't move the endpoints, but it's not a seamless roam that I can be in motion with my endpoint. It's my endpoint's over here, it wakes up, gets on the network, does its thing. It can be over here, wake up. So it's a pretty low requirement for workforce management, but it's a big requirement for dispatch voice. And we've tried to categorize what are the optimal solutions for each one of those applications. And LTE falls into many of these as being an optimal solution. So there are utilities out there, Ameren comes to mind immediately, where they were in the process of needing to replace several of these networks all at once and saw the opportunity to replace them with one giant LTE network. That's great. There are other utilities we've worked with who were just focused on their field area network and trying to justify LTE when what they really needed was a field area network, and oh, by the way, had some needs for low latency, pushes them off in the other direction. There is no right or wrong answer here. There is what is the best answer for your utility, for your application, for your need set, and go do it. So I've already said 2/3 of this in the course of going through the previous slides, but fundamentally, as you look at this problem, the first step is to understand what you have. What is your need set? What are the networks you need to replace today? What are the networks you need to replace in the future? What are the constraints of those applications? What is the spectrum available? And does the spectrum that's available to you serve those needs? And what are your choices? I mean, that can be a process in and of itself of going out and talking to all the spectrum vendors, doing the FCC database research to figure out what are your possibilities? And then given those possibilities, what are the costs? And given that, what makes the most sense for your utility to move forward? Because what you decide about the applications and what you decide about the spectrum are really going to drive both your CapEx and your OpEx costs going forward. The other thing that I would advocate you think about hard is risk tolerance. JJ and John got into a discussion in the last presentation about how do we build this for high reliability? And there are a lot of ways to do that, but just remember, every system at some point in time is going to have a problem. It's just a fact of life. Every system's going to have a problem. So you really want some workarounds or backups. One of the things that we talk a lot with our client utilities about is, are you comfortable having all of your operational systems and applications and your voice dispatch and your workforce management on the same network? Because at the end of the day, if everything goes to heck in a handbasket on grid control, what do you want more than anything else? You want to be able to dispatch your people to go fix things. And you can't tolerate all of it being out at once. But today there are a lot of ways to solve that. You can solve it with disparate systems that are purpose-built. You can also solve it by having the roaming agreements with your LTE system that lets devices roam onto not just one carrier, but any of the carriers, so that you can gain the reliability or availability or resiliency of all of those carriers at once. As you look into the future, the world is changing faster and faster, and having something based on standards is always going to be better, more comfortable, more flexible than having something that's built on a proprietary basis. So that's another big consideration. But the last thing that I would say, as I introduced Dewey Day to talk about the process they went through, is one size does not fit all. That's the key to me. When I hear somebody say, oh, everybody's going to do this, no, they're not. If you look over the last 30 years, everybody didn't do the same thing. If you look over the next 20 years, everybody's not going to do the same thing. There are different, better answers for different utilities in different geographic situations, different political situations, different financial situations. So it's not a one-size-fits-all market. And that's where you really need a bunch of smart people to come in and help you and work through it. And also, we are consultants, so at the end of the day, if the answer ends up being bad, we're your scapegoats. That's what we're there for. And we're happy to take to bear the cross. So we'll take questions at the end.
Why don't you go ahead and say, if there's a few questions now, I think based
Go ahead and
on
take
time,
them.
you scooted through. So
Okay, Mr. Moderator, do we have some questions at this point?